Hi everyone, welcome to my Core 3 Maths video. We're looking at the OCR June 2013 paper. What I'm going to do is I'm going to just work through it as if I'm doing the exam. Not done this one yet, so it's going to be a bit of a challenge. I've got my green formula book in my hand and a calculator in my other hand. So let's get on with what we're going to do. Question 1. We've got some integration. First integration is of 4 minus 3x to the power of 7 dx. Now this you need to do by recognition, by inspection, whatever you want to call it. I call it guessing. It's effectively something to the power of 7. Now if you're guessing what's going to differentiate to that, because we're trying to integrate and they're opposites, then you would guess something like 4 minus 3x to the power of 8. Your guess doesn't have to be brilliant because we come back and we improve our guess after. Okay, so if we do guess that, what we're going to get using the chain rule is 8 timesing by the power minus 3x to the power of 7, decreasing the power, and then we have to multiply by the differential of this because of the chain rule. So we've got minus 24 at the front. Okay, sorry if that looks like over it, it's just what it is. So our guess needs to be improved because we've got a minus 24 that we do not want. The way we can get rid of a minus 24 is if we divide by minus 24 here, 1 over 24. That will mean that when we carry this constant through, the 24 will cancel out the 24 and the minuses will cancel each other out. So this is our answer, but you just write it again and you make sure that you do not forget to put plus C. Okay, next one is a bit trickier. So we're trying to integrate 1 over 4 minus 3x with respect to x. 1 over something integrates to ln of that thing. So our guess this time is going to be ln of the modulus of 4 minus 3x. Now, when we do differentiate that, ln of something differentiates to 1 over it. However, we have to use the chain rule, and that means that we're going to have to times by the differential, which is times by minus 3. We want to get rid of that, so we times at the start by the reciprocal, which is minus 1 over 3. And then, when it comes down here, these two things are going to cancel out. So our answer is minus a third ln 4 minus 3x plus C. Question 2. Using an appropriate identity in each case, find the possible values of, for part 1, sine alpha is all you need to know, not the angle alpha, if you know that 4 cos of 2 alpha is sine squared alpha. Now you turn to your green book because it's given you a clue about using appropriate identities. So you go to your bit with all the trig, which is page 3, and you're looking for something that resembles cos of 2 alpha. Now there's nothing that says that, but there is something that says cos of a plus b. Now if you think about it, if a is alpha and b is alpha, then you've got yourself cos of 2 alpha, which we require. So you use this formula from a green book with a and b as alpha. And when you do that, you're going to get, I'll do it in green because it's coming from a green formula book, cos alpha times cos alpha, that's cos squared alpha, minus sine alpha times sine alpha, aka sine squared alpha. Okay, so we've just substituted in. Now, looking at the question, you want sine alpha, so let's write cos squared alpha in terms of sine. Okay, so from core 2, it's 1 minus sine squared alpha, because cos squared alpha plus sine squared alpha is 1. So that means that this whole bracket, and some people just remember this, that cos 2 alpha is 1 minus 2 sine squared alpha. So don't forget we've got the 4 times by all of that, and it's equal to sine squared alpha. So let's expand out our bracket. We get 4 minus 8 sine squared alpha equals sine squared alpha. We want to bring them all to the same side, the sines that is. So we add 8 sine alpha onto both sides of the equation. Can you see 2 square numbers here? How lovely is that? Okay, now divide by 9 and we'll just swap sides. Sine squared alpha equals 4 over 9. Do not forget that when you square root, you want to do plus or minus. So sine alpha, by square rooting both sides, is the plus or minus version of 4 over 9. Using your core 1 skills, you can square root the 4, square root the 9. It's plus or minus 2 over 3 is your answer for sine alpha. You do not need to go any further. 3 marks. Part 2. Sec beta. We want to find sec beta. And we know that 2 tan squared beta. Now remember, tan is sine over cos. Okay. So we're going to change those. That works because these little squareds are meaning that each thing is squared. So if you've got sine theta over cos theta all squared, that bit in the middle is going to go to tan squared. Okay, and the way we can write sine, this just means, you probably already know this, but just to make sure, sine beta all squared. Okay, anyway, carrying on with what we're doing. 3 plus 9 sec. My trick is, look at the third letter. You've got sec, you've got cot, you've got cosec. If you look at the third letter, it tells you what it's the reciprocal of. Okay, in our case it's sec, so it's 1 over cos. Okay, cos beta. Now I've written it like this so that hopefully we can spot how to simplify that equation. Well, what we can do is we can times up by cos squared beta. So let's have a go at doing that. Let's times up by cos squared beta. So we get 2 sine squared beta left on the left-hand side. 3 cos squared beta. Remember, we times everything by cos squared beta. We've already got a divided by cos beta here, so we're just going to be left with cos beta on the top. That's starting to look like something from core 2 a little bit, but we want to make sure that all our trig things are the same. And we actually want to know over cos, okay? So it's really going to help us if we can change everything in terms of cos, okay? So that is what we're going to do. There are other ways to do this, but don't worry about that. So we're going to change this to 1 minus cos squared beta. And we're going to times out with the 2. So we're going to get 2 minus 2 cos squared beta equals 3 cos squared beta plus 9 cos beta. Right, we're going to simplify. We're going to add this to this side, and we're going to take that away so that we've got 0 equals 5 cos squared beta plus 9 cos beta minus 2. Okay, that is a hidden quadratic. It's something squared plus a number times something plus a constant on its own. So it's a hidden quadratic, and you can make a substitution such as let cos beta equal y. Okay. So what we can do now is we've got 5y squared plus 9y minus 2. I have a weird way to try and factorize this, if it does factorize. Okay, if you've seen my other videos, you will have seen it. basically, I think we've got 5y squared, so I'm going to put 5y in both brackets, but that's cheating, and it's not even going to work, because when we times out, we're going to have 5 times too much. So we cheat again to make it work. We divide by 5. Okay? So that means that what we need to do now is look for numbers that multiply to make minus 10 and add to make 9. Can we think of any there? So it's going to be plus 10 and minus 1. Okay. Now the trick is that we can get rid of this fifth in one of the brackets from this bracket. So we get, we divide this first bracket by 5, y plus 2, 5y minus 1. Okay. We solve this equal to 0. So that means that y equals minus 2 or y equals fifth. Now let's remember what y stood for. Okay. Y stood for cos b. So i.e. Cos beta, sorry, not b, equals minus 2, or cos beta equals a fifth. Now one of these doesn't work. Think of your cos graph. Okay, cos is cool, it starts at 1. You can snowboard down it. Okay, so the cos graph goes between 1 and minus 1 only. This does not work. Try it in your calculator, cos to minus 1 and minus 2, it does not work. So the only solution we're interested in is this. Now remember, the question asked you for sec beta. Okay, so the last step is just to change to sec beta. And sec beta is 1 over cos beta. So you want the reciprocal of 1 over 5, which is 5. Job done. Question 3. The diagram shows a container in the form of a right circular cone. Okay, right circular cone, so you've got the right angle here. The angle between the axis and the slant is alpha, as shown on the diagram, and alpha equals tan to minus 1 over half. It's a strange way to write things. Initially, this container is empty, and then liquid is added. Okay, so we're adding some kind of liquid to this at a rate of 14 centimeter cubed per minute. Okay. Now, if you just think about the units, it's telling you volume over time. So that gives you a clue about the differential. The rate of change of a volume with respect to time is what this rate means, okay? And it is 14. So we convert that into words. This very important sentence here. The depth of liquid in the container at time t minutes is x centimeters, okay? That is also shown on the diagram for you, x. Show that the volume of the liquid in the container when the depth is x is given by this. Okay, it's a rate of change question. It's quite tricky, and you really need to know about how to use rates of change, the chain rule, all that type of thing. Okay, so what we're going to do is we're going to think, well, the volume of a cone is this. It's given for you. Okay, so it's a massive clue that you're going to want to use that. A third times pi r squared times h. It's very nice of them to give this to you. If you play a game of spot the difference here, what we're trying to do is we need an extra quarter, and we need to make this into x cubed somehow. We already have the pi that's the same. So we'll start with what we've got in red, and we want an expression in terms of x for all these things. Now the radius here is r. So if we take this triangle over and think about what's going on, we've got x, we've got r, we've got alpha. Now think about this thing. Tan to minus 1 of alpha of a half gives you alpha. That's a strange way to write what we're more used to. Take tan of both sides. Tan alpha is a half. So think about the diagram. That means that tan of your angle is equal to a half. So think of your SOHCAHTOA. Tan is opposite. Tan of any angle is opposite over adjacent. Okay, opposite the angle is here, adjacent is here, and that's a half. So these are in the ratio of a half. Okay, so we can basically say that r over x is a half. Okay, I hope that makes sense. It's all from GCSE trigonometry there. That means if we want an expression for r, we can just times by x. So r is x over 2. Okay. And now we need to think about h. Well, look, h, the height of the cone, is just x. Okay. So we know that fact, and we know the fact that h equals x. So these two bits of information, here and here, we substitute in. Obviously, if I had a clean page, I would be setting this out a lot better. So I do apologise for that. R is x over 2. That's going to be squared. H is x. Times all this together. And guess what we are going to get? X squared over 4. This is what we predicted we wanted. Okay? And that's the result. 1 over 12 pi x cubed. You can give yourself a tick, you know it's going to be right. Okay. So, the good thing about this is you were given that if you couldn't figure it out to use in the next question. So part 2. Find the rate. It's all about changing words into differentials here. Find the rate at which the depth of the liquid is x, is increasing at the instant when the depth is 8. The instant, when you're not explicitly told what your differential is with respect to, it's going to be time. It's very interesting to think about how things change with respect to time. So the rate at the change of depth with respect to time is dx by dt. And we want to know about when the depth is x. Okay? The depth is 8, sorry, when x is 8. That's your question in maths, which is a lot nicer than these words. Give your answer in centimetres per metre, correct 2 decimal places. Don't forget to get your rounding correct. Remember from the last slide that we said that dv by dt is 14. We've not actually used that yet, but we're going to use it now for sure. dv by dt is 14. Now think, we want to make up dx by dt. At the minute, what we've got to use is dv by dt. We need a clever way to combine dv by dt with something to get dx by dt. Now, if you know your chain rule, this will be a lot simpler. Okay, you can think of these differentials like fractions. They're not, but they behave very, very similar. So what you want to have here is dx by dv. Because of the chain rule, these two things are going to cancel each other out. And you'll be left with dx over dt. So our plan is that if we can find dx by dv, we can combine it with 14 and we've got ourselves an answer. So our aim is to find dx by dv. So we need a relationship that combines dx and dv. Sorry about that, completely messed things up there. I was trying to move this writing just out of the way. As I said, I've not got a lot of space, to be honest. Okay, move this up. So let's try and think about an expression for x in terms of v. Now remember the last question that was on the previous slide? V equals a 12th pi x cubed. 12 pi x cubed. Okay, so we've got v in terms of x. So what we can do is we can find dv by dx and then do a clever trick I'll show you in a second. dv by dx is a constant, a 12 pi. That's just a number, so treat it as a number. Okay, if that was just a normal number, it's a core 1 differentiation. Very, very simple. What you're going to do is you're going to times by the power, so you get 3 over 12 pi, and decrease the power. 3 over 12 is a quarter, so it's going to be a quarter pi x squared. Okay, or pi x squared over 4, which is going to be more useful for what we do now. If the rate of change of v with respect to x is pi x squared over 4, the rate of change of dx by dv is 1 over the rate of change of dv by dx. I told you they behave very much like fractions. Now saying 1 over something is just like saying the reciprocal, so it's 4 over pi x squared. Okay, now as we said, we can combine these two using the chain rule to get dx by dt by timesing dx by dv, which is 4 pi times x, 4 over pi x squared, times by dv by dt, which we were given in the question as 14. 4 times 14, double it and double it again, 2856 over pi x squared. And we said at the start we want to know this value when x is 8. You have a calculator, let's put it in our calculator. 56 over pi times by 8 squared, or 64, and we get 0.28. It's actually 2785211,504, but we've been told to round to 2 decimal places and give our answer in centimeters per minute. Okay, that's question 3 done. Moving on. Question 4. Find the exact value of the gradient. You should have alarm bells in your head saying, gradient, we're going to have to differentiate of the curve, this weird looking thing, at the point for which x equals 4. So this time we want dy by dx at x equals 4. That's our question in math speak. Now y is not presented very well. Okay, so what we want to do is we want to write it in a better format. What I mean by that is that you want 4x minus 7 to the half, because square root is just power of a half is another way to write square root. And then it's personal choice on the second thing. You can either use the product rule by bringing the denominator up to top as a negative power, or you can go for the quotient rule. Okay, so we've got chain rule here, and we've got quotient rule here. Okay, so let's color code these actually, so we don't get confused. We're going to do each one separately, and let's go. First one, we're going to treat this as one thing to the power of a half. Well, if we were to differentiate that normally, we times by the power of a half, and we'd take one from a power. Because it's not just any old thing, because it's something to do with x, not just x, we need to times by the differential of this thing, which is just 4. That would give us 4 over 2, which of course cancels to 2. Second one we're going to do in green. Quotient rule. Okay, the quotient rule is in your formula book, but this is one formula that I like to remember in words as opposed to using the formula book. If you were interested, it is on page 4, right at the bottom. Okay, but this is what I do. I say, this is the first, by the way, this is the second from what I'm going to tell you now. Differential of the first times the second minus the first times the differential of the second, which is just 2. So that's going to go to 8 all over the second squared. Okay. Finding, so that is, why have I put y? Someone should have told me that through the speaker. dy by dx, obviously. And we want to know the value at x equals 4. Personal choice here. You could start to simplify that yourself, or you could put that all into a calculator. I would actually just write this as what it is when you're going to put it in your calculator, which is the square root of 4x minus 7, because the negative power takes it to the bottom. Okay, maybe I would simplify this bit. So it's going to be 8x minus 4. And look at what happens. That's quite cool. This 8x is going to cancel this minus 8x. So you get minus 4 over 2x plus 1 squared. That's dy by dx. We want to substitute in x equals 4. And we do this on our calculator. Just be very careful when you put things in not to make mistakes. So I'll do the same. 4 times 4 minus 7. I'm literally typing in what we've got in that last line. Onto the second part. You can use the fraction button on your calculator, and you can get it just to look just like it does on the board. Squared. Done. And you get 50 over 81. I bet it's asked for exact form. Has it? Has it not? Yeah, exact value. Always give exact form unless it tells you to round. It's much better, much more accurate. At the point for which x is 4, job done. Okay, moving on. Question 5. Give full details of a sequence of 2 transformations needed to transform the graph y equals mod x, modulus of x, to the graph. Our target is 2 brackets x add 3. Okay, so what we want to try and do is we want to try and take x and make it into this. Now believe me, core 3 transformations are a lot more difficult than core 1 or core 2 transformations because order matters. It's so important. I'm going to write that down. We know, we can all see that we're going to be adding 3 to x and we're going to be times an x by 2. Okay, but order matters. Watch this. If we start with x, think of it like a function machine. If we start with x and we add 3, we get x add 3. Well, it's not quite like a function machine because we just do things to x, so I kind of lied there. Now if we times x by 2, we get 2x add 3. That's not what we want. Okay, let's try it the other way around. If the other way around, we start with x and we times by 2, and then we add 3. Start with x times by 2, you get 2 times x. Now, here's the important difference. We add 3 to x. Now, x is being times by 2 already, so it's going to give you what we want. I hope that explanation made sense. It's a tricky thing to get your head around, but all in all, I'm telling you that order matters, and what we're going to do first is we're going to do the times by 2. And we'll talk about what that actually means in a sec. So to our value of x, we're going to times by 2 to get 2x. Now, what is that in words? i.e., that is in words stretch. We're doing it to x, so it's the opposite. So it's a scale factor of a half, reciprocal, in x direction. That's the first transformation. Okay. Now, as we talked about, we're going to take our x and we're going to add 3 to it. Okay. So that means that we're doing it to x again, so it's the opposite. And then we translate, we can write it as a vector by vector minus 3. It's the opposite, 0. Okay, it's 3 marks. Right, let's clear that off and let's try to solve this. We might need what we just talked about, sketch graph. And like I've said, we do need sketch graphs. That's how you solve inequalities with modulus in. Modulus of x. Okay, so mod x, it's looking like y equals x, but then it gets to y equals 0, and it's not allowed to be a negative answer, so you have to bounce up. That's y equals the modulus of x. We've just talked about how we can transform y equals the modulus of x to this thing. So we're going to do that is stretch by a scale factor of a half in the x direction. Okay, so that is going to go scale factor of a half like that. It's the same, incidentally, as stretching by a scale factor of 2 in the y direction, but there you go, don't worry too much. We'd have still got the marks if you put that by the way. And then we said we were going to translate it minus 3, 0. 1, 2, 3. Okay, minus 3. So the two key values that we're thinking about are here and here. And when we solve the inequality, these are our critical values. To find those values, all we do is we set the two things equal to each other, but not the whole thing. We think about, okay, this graph is just y equals x. This part of the graph is we took our negative answer, we made it positive. We can do that by multiplying by minus 1. So that's y equals minus x. Okay, and this purple line, this one is the same as before. Y equals 2x add 3. This one is the negated version of that because you've bounced it up. Okay, so this one is going to be y equals minus 2x add 3. Right, so to solve each point, we just zoom in on where we're interested. If we're interested in here, we'll call that part 1. What we're going to do is we're going to be solving y equals minus x with y equals this, okay? So equate them together. You can cancel the minuses now. Times out your bracket. Just simplify. We're going to get our x's here, take the 6 across. So minus x from both sides and minus 6 from both sides. Okay, this value here is minus 6. Right, next bit. Next part, we zoom in here. So the green line is still the graph of y equals minus x. And this time, we'll call this one 2. This time we are going to equate with this equation. 2x add 3. Expand the brackets. 2x add 6. Okay, and then simplify. We get our x's over here. This time, minus 3x equals 6. So divide by minus 3, x is minus 2. Done. Right, so what? So we found the critical values of where we're interested, but we have not solved the inequality. Look at which way around the inequality is. The graph that has to be bigger is this one. Okay, the graph that has to be bigger is the green one. Now, when is the green line bigger? And when I say bigger, I mean when is it higher than the purple line? Hopefully you can see the only place is here. And you can look along the line and compare. Here, purple's bigger, green's bigger, purple's bigger, etc. Okay? You can compare as you go along. Because this is steeper, it will always stay above there. So we want the values between minus 6 and minus 2. So that is what you give as your answer. You look that the inequality did not have an equals to as well, so you do not use one either. So x is between minus 6 and minus 2. Question 6. We've got an integral, definite integral between the limits 0 and 8, and we're going to be using Simpsons Rule. We're going to have 4 strips, and the area that we find is denoted by A. So we want to find, for part I, the area between 0 and 8 under the curve ln 3 plus x squared. Okay. Now, Simpsons Rule, if you look in your formula book, is on page 5, a third times h. H is the height of your strip. Okay, so it's actually the width. And then you times your first y and your last y plus 4 times your odd y's. I know it says y1 up to yn minus 1, but they're your odd y's. You'll see what I mean in a second. Times your 2 times your even y's. Okay. This is how you can think about the formula. So we need to know our different y values. So what we're going to do is we're going to do a little table, and we're going to think we're going between 0 and 8 on our graph, whatever the graph looks like. And we've got 4 strips. So guess what? You don't really need the formula. It's going to go 2, 4, 6, 8. Okay? To split it up like that. So they are the x values that we're going to use. And we want to know the y values. So the x values 0, 2, 4, 6, 8. The y values, these are going to be, by the way, y0, y1, y2, y3, y4. Okay. You grab your calculator, and for the first one you put 0 into this formula, so 0 for x. So in your calculator you type in ln of 3. You can actually keep this exact. Be 1.0986, etc. If you don't keep it exact, I'm going to keep it exact. For 2, you're going to have ln of 3 plus 2 squared, so it's going to be ln of 7. Number 4, it's going to be 3 plus 16, so it's going to be ln of 19. Y3, it's going to be 3 plus 6 squared, so 39. For y4, it's going to be 3 plus 8 squared, so 3 plus 64, ln of 67. So we've got all our values. First value and last value are going to go here in your formula. Okay, I'm just going to color code. But oddwise, what I mean by the oddwise are you look at these index numbers. Okay, so it's going to be ln 7, ln 39. It's going to go in here, added up, remember, and the last ones are going to be the evenwise, which is just ln of 19. Okay, so now, remember we said that h was how wide the strips are, which is 2. So we're going to change that to 2. And we're going to type all of this into our calculator. Here, remember, you're putting ln 3 plus ln 67. Here, you're putting ln 7 plus ln 39. And you can type it in with me now. Okay. So 1/3 or 2/3 if you want to do it all in one go. Times by, you need brackets. And then you want ln 3. We're just being more exact by using the exact form. Plus ln 67. Plus 4 times, and then you need more brackets. Oddwise, so that's going to be ln 7 plus ln 39. Close your brackets. Plus 2 times, and then brackets. And there's only one here, ln 19. Don't forget to close your big brackets. And then in your calculator, you should be getting 22.4200467. Look at the question, 3 significant figures. So it's going to be 22.4. We don't know units, but we know its area, so we can put square units for that one. Okay? Right. So, moving on to part 2. Let me just erase what we've done so far, apart from the key bits. So part 2, explain why an approximate value of that is 2 times the area we've just found. Okay, this is using your log laws. Now you have to notice that what we've just talked about was ln of 3 plus x squared. Now we want to think about ln of 9 plus 6x squared plus x to 4. Okay, now this might not be obvious at first, but we can factorize this term here. So let's just first off write it the way round that we like for when we factorize. It's actually a hidden quadratic if you want to think about it like y equals x squared. You can do, okay? So it's y squared plus 6y plus 9, which is going to factorize to y plus 3 squared. Okay. Now you didn't have to make that substitution. I was just showing you how it works. You could have gone straight to the factorized version, which is x squared plus 3, or equally 3 plus x squared. Okay, squared. So that means that this thing is equal to ln of all that. Using your laws of logs, you can bring this power to the front. Okay, so if we bring that power to the front, we're going to get 2 ln 3 plus x squared. Okay, so a equals the integral of this. Okay, now the integral of 8 of what we were talking about can be written as not infinity, we're talking about 8. 2 times ln of that. Okay, now because 2 is a constant, it can be brought outside the integral, okay, equals 2a. So that's shown it. We've got part 3, which is explain why an approximate value of this integral is a plus 8. Okay, so let's have a think about that one then. Let me just clear off the work we've just done. So be thinking about how you can use log laws to write this separately, differently. Okay, so ln of 3e plus e times x squared. You should notice that e is a common factor here. Okay, so we can factorize out e, and we're going to get 3 plus x squared. So you might be able to see that we've got ln of that times that. Okay, and because of log laws, when we times, we add. So it's going to be ln of e plus ln 3 plus x squared. Now we're trying to prove this, so we need to know why it's 8. And if we are integrating, okay, so between 8 and 0, when we integrate this, we can do it one at a time. So integrate that, integrate that. Now the integral of this, ln of e, they're not reciprocals, inverses. So they're going to just cancel down to 1. Okay, and when you integrate that, you're going to be going between the limits 8 and 0 for x, which is going to give you 8, a plus 8. Okay, question 7. The diagram shows the curve y equals f of x. F is a function defined for all real values of x by f of x equals 3 plus 4e to the minus x. And we have to state the range of f. Now, if you remember, the domain is your inputs, which are referring to the x values, and we're told that all real values are going into our function. And the range is the output, all possible answers that you can get, basically. So the question is saying, what answers can we get from this function f of x? If you look at the graph, we have a horizontal asymptote. So the only answers that we can get are above this line. So our challenge is to find out whereabouts that line is. If we look at the equation for f of x, we can see it's a transformation of e to the x. It's been reflected, it's been stretched, and the one that we care about is it's been translated in the y direction by 3. So that means that this value is 3, and our function can take any value above 3, but not including 3. So our range, we can just write f of x is greater than 3. That's it for 1 mark. Part 2. Find an expression for f to the minus 1 of x, that is the inverse, and find the domain and range of f to the minus 1. So, I always say that set your equation equal to y. This is our current equation, okay? And we have y equals f of x. If we want to take the inverse of both sides of this, f to the minus 1 of y, then we've got a double inverse here. Well, the inverse for function, which just counteracts each other. So we have that f to the minus 1 of y equals x. I'm just explaining why what I'm going to do soon is going to work. So we'll refer back to this in a minute. We rearrange y equals to get x as a subject. So minus 3 divided by 4 equals e to the minus x. Take ln of both sides to get ln of y minus 3 over 4 equals minus x. And obviously we want x equals, so x equals minus ln of y minus 3 over 4. Now you may have been taught, and I sometimes say, now you just swap y and x. That's a trick that works, but the reason why it works is because of what I rearranged here. X is f to minus 1 of y. When we find the inverse, f to minus 1 of y equals that. Okay, now that's f to minus 1 of something equals minus ln brackets of that thing minus 3 over 4. Now that thing is going to be our input, and obviously we usually use x as our input, not y. So that's why we swap the letters around. Okay, so that is the equation. We want to state the domain and range. So to state the domain, we just say about x. Now what actually happens, I'll just quickly show you on the graph, is that when you find the inverse, you're finding the reflection of this line in the line y equals x. And that's to do with what I talked about. We are swapping y and x around. Okay, so the new asymptote is going to be at x equals 3. And if we can reflect it, it's going to be, let me get this right, something like that. Okay, so that blue line is y equals f to minus 1 of x. And hopefully you've noticed, I've done a video on this actually, of why this works. I've actually done it with inverse trig functions, but the same still applies. The range and the domain swap. So the range is going to be the old domain, and the new domain is going to be the old range. The old range was this. So x is greater than 3, and the range, any value that you can get, is going to be anything. You can get any answer out of this new function. Okay, so f to minus 1 of x is just any real number. It can be anything. Okay, that's part 1 and 2 done. Part 3, and that's referring to what I've just talked about. The straight line y equals x meets the curve y equals f of x at the point P. Okay, so this is the point P. By using an iterative process based on the equation x equals f of x, with a starting value of 3, find the coordinates of a point P. Show you're working and give each coordinate to 3 decimal places. Right, so when we're saying y equals x, we're talking about this green line. And when we're saying f of x, we'll do this one in red. Okay, we want where the red and the green line cross. Just a little key for you there. So where they cross, simultaneous equations, we can solve by setting them equal to each other. Okay, so when we equate those, we get x equals 3 plus 4e to the minus x. Now our starting guess is x0 equals 3. Now there's a very special way to do this in your calculator, which I'll show you now. Okay, by the way, that's just our rearrangement. That's an equation. To use the iterative process to solve it, your new guess is going to be obtained by putting your previous guess in, and that goes back into your equation. So it's like a cycle. Put this in, get an answer, put that in, get an answer, and that keeps going until you either converge or diverge. Now I want you to type this into your calculator as, first of all, a bit of a trick, just type in 3 equals onto your calculator. That's going to mean that 3 is saved in your calculator. Now I want you to type in 3 plus 4 e to the minus ants. That means that your previous answer is going to be into your equation. So let me type that in now. 3 plus 4 e to the minus ants. Okay, and you get 3.19. Let's just read how many decimal places we want. 3 decimal places, 3.199. That's our first iteration. You can use an arrow now. Press equals again. That's why I told you to set it up in this way, so you don't have to keep messing about. Press equals again. Each time you press equals, write down your answer. You only get marks on this question if you show you're working out. Okay. 1/6. We're going to keep doing this until it stops changing to 3 decimal places. Okay. So that is our x coordinate for P. That is this value here. So found our x coordinate. We want to find our y coordinate now. So what we're going to do is we're going to sub in our answer into the equation. Doesn't matter which one, y equals x or the more complicated one. Obviously, the easier one is y equals x because you've already got your answer. So your coordinate is going to be x is 3.168 and y is 3.168 for 4 marks. How is P related to the curve y equals f of x and y equals f to the minus 1 of x? If you refer back to the diagram I drew on the previous slide, it's where the 2 lines intersect because they're reflections of each other. If you're right within the mirror, then you're going to be touching. So you can see on my diagram previously, that is where they cross. Okay, so you can just type P is where they intersect or cross. Okay. Question 8. Express 4 cos theta minus 2 sin theta in the form r cos theta plus alpha. R is greater than 0 and alpha is between 0 and 90. This is where you will need your green formula book, and you're going to need the formula in particular for r cos theta plus alpha. So go to your trig section, it's page 3, and you look for the bit that says cos A plus B. Okay. Now your A is theta and your B is alpha. In this case, you use the formula. Now because of this r at the front, we're going to have r times the whole thing. Okay. But because we're timesing it by the whole thing, we're effectively going to multiply in. So I'm going to put an r to be multiplied in front of each term instead. So our first term is going to be cos A cos B, aka cos theta cos alpha. And our second term is going to be, remember we need the r as well, sine theta sine alpha. And I've just re-looked at the formula, and that should be a minus. Okay. Right, so we set this up using the formula. Now this is where we're going to play spot the difference now. We want to write this in that form. Okay, so what we've actually got that we've started with is 4 cos theta minus 2 sine theta. Now what I mean by spot the difference is you're trying to force this to be like that. Okay, now you already know that this side can be written like that. So if you force the 2 things on the right to equal each other, you're going to have it in the required form there. So we've already got cos theta in both on the first term. So that means to make them exactly the same, r cos alpha must equal 4. Okay, so that the 2 things are exactly the same. So that's one equation. R cos alpha equals 4. From the same way on the second term, you've already got the sine theta in both, so you don't have to worry about that. And to force them to be the same, that means that r sine alpha must equal 2. Okay, I'm going to show you the long way, but when you've done these a few times, you can take shortcuts, but I want to explain where the working out is coming from. So the long way, okay, what you're going to do is you're going to think sine over cos is tan, so you're going to do equation 2 over equation 1, okay? So r sine alpha over r cos alpha, the r's are going to cancel, sine over cos is tan alpha, and when you do 1 over 2, you've got 4 over 2, which is 2. That means that alpha is going to be tan to the minus 1 of 2. And we are in degrees, so make sure that your calculator is set to degrees. I'm going to change mine now. And you can do tan to the minus 1 of 2. (63.4). Okay, 63.4 degrees. Right, the way that you get the next term, r, the next unknown, is you square all this and you square all this. And you use the fact that sine squared plus cos squared is 1. So let's do it the long way to show you what's going on. So when you square the first one, you're going to get r squared cos squared alpha plus r squared sine squared alpha. We're adding equations 1 and 2 equals this squared plus this squared. 4 squared is 16. 2 squared is 4. Okay. Now the nice thing that you can do here is you can think you've got r here and r here, r squared. So you can actually factorize out r squared, and cos squared theta plus sine squared theta is 1. So you get that r squared equals 20. Now, when you square root, you usually need to do plus or minus, but refer back to your question that r is greater than 0. So you just need the positive version of root 20, which is root 4 root 5, which is 2 root 5. Okay, so we've forced it into that form with r as 2 root 5 and alpha as 63.4. Okay, I'm going to clear all that ink off and just leave the final thing that we found out. Okay. If you get good at this, you can go straight to the fact that tan alpha equals 2 and just do that working out, and go straight to the fact that r squared equals 4 squared plus 2 squared. So if I was doing that question, I'd go straight to these two things and solve it really quickly. That's why it's only 3 marks. But in this video, I'm showing you what's going on, hopefully. That's the idea. Anyway. Part 2. Hence. Notice that word hence. You're going to be using what you've just done. Solve the equation that 4 cos theta minus 2 sine theta equals 3. And we're going between 0 and 360 degrees, so bear that in mind. Now, we've just gone to a lot of effort to write this in a certain form, okay, which I've handily left above there. So actually, that thing equals 3. And that top equation, believe me, is much nicer to solve than this equation, because you've only got one trig thing. You haven't got cos and sine, you've just got cos. So that's why it says hence. And that highlighted one is what we're going to use. Right, so to solve, we're going to divide by 2 root 5 and get that cos theta plus 63.4 degrees equals 3 over 2 root 5. Okay, now I solved this maybe a different way to what you've seen before, because I'm just going to think that is cos of something. So I'm going to think about my cos graph. Cos is cool, so it starts up here. It's cool because you can snowboard down it. We're in the range of 0, 360 for theta, which we'll come back to in a second, because that is not theta. So theta is between 0 and 360. But if we have theta plus 63.4, that's going to be between 63.4 and 360 plus 63.4, which is going to be 423.4. They're all degrees. Okay, so back to our graph. We're just talking about cos of all that. So we want one answer to this. And we can get one answer by doing cos to minus 1 of the right-hand side. On my calculator, we're still in degrees. Cos to minus 1 of 3 over 2 root 5. Sorry about the handwriting there. I might just make that a bit neater for you. That's definitely a 5. And we get 47.9 degrees, 47.86, etc. So to one decimal place, 47.9. So our answer for, let's call it A for angle. Okay, our answer for our first angle is 47.9. Right, so that means that we're going to get more answers. We're going to get an answer here, and we're going to get an answer here. But that's not our final answer for theta. To get our final answer for theta, we need to add on, well, not add on, we need to take away. I'll show you why. It's because that's theta plus 63.4 equals that. So we take away 63.4, and we get our first answer for theta is out of range. Because we're doing this takeaway, it's going to be out of range if it's less than that, which this is. So let's extend our graph a little bit. We might actually need to go to here. Okay. Now this answer for A, the angle, we're going to get by doing 360 minus this, because this is a constant length. Okay, so we're coming away from 360, that constant length. So 360 minus 47.9. This is going to be our first proper answer. 312.1 degrees. Okay, we need to test this answer too. So we're going to do 360 plus 37.5 for that one. 360 plus 47.9. Okay, and you're going to get 407.9. That's going to be in range because our range for our adjusted angle is there. Okay, so it's getting a little bit messy. That one is 407.9, and that's for just the angle A. We need to take away 63.4 to get the actual answer. Take away 63.4 equals 344.5. Okay, so there are two answers. That's not theta. There are two answers for theta. Okay. Right, greatest and lowest values for 5 marks. Right, okay. I'm going to clear all this off, and we're going to have a look at the next bit. This is all about knowing your graphs and about trigonometric graphs. Okay, I'll move that highlighted stuff in case that's getting in the way. So, determine the greatest and least values of 25 minus 4 cos theta minus 2 sine theta squared. Okay. Now, it's still under the word hence, so we're still going to be using what we did before. Okay. Now, if you spot that this stuff in the middle is the same as what we had before, that means that we can replace all of this by our new stuff. Okay? So I'm going to drag it into that bracket. So it will move one bit at a time maybe. Okay. And let's just rub the rest off. So, okay, carrying on then. The most important thing to notice in part B is that we've got something that is squared. Okay? And you need to know that if you've got anything squared, you always get a certain type of number. If you've got a positive squared, positive times a positive is a positive. A negative squared, negative times a negative is a positive. So anything squared gives you a positive number. So we know that what we get as a result from this thing here is always going to be a positive number. When you realise that, and when you notice that you're taking away this positive number, if you want the maximum value you can, all you're going to do is make this be 0 for the max. So the max value that you can get is going to be 25, because that's what you're going to have left if you don't have to take anything away. And we need to know what our value of theta has to be to make this be 0. Okay? So it's 2 root 5 times by a trig function. It's a trig function that we need to make 0. Cos is cool, it starts at 1. Okay, that's one period of 360. Crossing, well not crossing, but in the middle at 90, 45. I know it's not really to scale that well. I've done that wrong, sorry. Period of 360 with 180 in the middle, 360 here, 90 here, 270 here. That is y equals cos of your angle, I don't know, x. Okay? So, our angle here that we're talking about is theta plus 63.4. I like to use the original graph with this as our angle x. Okay? Now to make cos of something to give you 0, you should know that you're going to be at 90 or at 270. Okay, because that's where you're crossing the x-axis. So when this happens, the whole angle is 90, which means that theta is going to be 90 minus the 63.4 degrees. Okay, so it's going to be 90 minus 63.4, and that gives us 26.6 degrees. So that's the maximum downward. The minimum, we need to think about the smallest value we can get from the whole thing, and that means that we want to take away as much as we can. So we want to make this big. Okay? We want to make it large. Now, the largest that we can make it by looking at the cos graph is if we're on 1 or minus 1. 1 or minus 1, etc. Okay? I'm saying 1 or minus 1 because remember we're squaring it, so minus 1 would be the same magnitude, same size as 1 would when you square it. Then you're timesing this by 2 root 5. So it's going to be 2 root 5 times plus or minus 1 squared, which is going to give you 4 times 5, which is going to be 20. So the min value you can get is going to be your 25, take away the 20, which leaves you with a value of 5. We want to know the smallest possible positive value of theta when this happens. So the angles are here, but think about if we start as for our angle x here, we're then going to have to take away the 63.4 and we're going to fail. So we go on to the next possibility here. We're starting on 180. Okay? And we want to take away the 63.4 to find out what theta is. So that's going to be 116.6, sorry, not 117.6, 116.6 degrees. Okay, so that is your 5 marks. We have solved it. Right, moving on to the final question of the test, question 9. We've got a graph and it shows y equals e to 2x minus 18x plus 15. That's the equation. The curve crosses the y-axis at the point P, as labelled on the diagram, and the minimum point is Q, as labelled on the diagram. The shaded region is bounded by the curve and the line PQ. There's the line PQ. Okay, and you can see the shaded region. Now I'm already thinking in my head what it's going to be asking us to do. It might be nice and split it up for us. Yeah, so it's splitting it into parts. Part I, show that the x-coordinate of Q, which is here, is ln 3. Now we need to know that a minimum point is a stationary point. And a stationary point happens at dy by dx equals 0. So we need to first off find dy by dx by differentiating. When we differentiate e to 2x, we use the chain rule, okay? And it's going to be 2e to 2x. If you don't get that, just ask me in the comments. Differentiate minus 18x, you get minus 18. So we want to solve this when it's equal to 0. So we're solving 2e to 2x minus 18 equals 0, aka 2e to 2x equals 18, adding 18 to both sides. Divide by 2, e to 2x equals 9. Take ln of both sides. Ln of e to 2x equals ln of 9. Now, ln and e are inverses, so we're going to undo each other. You're going to be left with 2x equals ln of 9. And then that gives you that x equals a half ln of 9. You now use your ln laws, your log laws, to bring 9 up as a half up to the power of the 9, okay, or 9 to the power of a half, shall I say. So that's going to be ln 9 to the half. Half is square root, so we've shown it ln 3, like we wanted to. Okay, first bit done. Find the exact area of the shaded region. So I'm going to erase what we've already done, and we're going to need the fact that this is ln 3. It could have been mean on this question. It could have asked you to just do all this outright for 11 marks, I guess. Okay, but it's been nice. It's given you a big clue of the limits that you're trying to integrate between. So let's try and fit this all onto one page. Okay, so we've got very clear limits between 0 and ln 3. If we come up with a kind of plan, then that's going to help us to find the shaded area. So always think of your plan first. The plan that I'm thinking of is thinking of this as a trapezium. Find the area of the trapezium. Integrate under the curve. Find this blue area. Take that shaded area away from the area of the trapezium, and job done, we will have the shaded area. Okay, so that's our plan of action. Now let's get down to business. For the trapezium, we need to know this height, we need to know this height. So, ln 3 here is the x-coordinate in your equation. So to get the y-coordinate, which is this bit, we're going to sub in ln 3. And to find out what y is. So e to 2 ln 3 minus 18 ln 3 plus 15. Okay, you can either do that in your calculator, or it's probably asked for exact form, so avoid using your calculator too much. Okay, the 2 goes up as a power, e and ln are inverses, this becomes 9 in the middle, so you get y. We're going to keep it as ln 3 because that's exact, plus 15. we will just now put the 15 and the 9 together to get 24. Okay, right, so that's our first step done. We know this height here, and I've just put a star next to it. Let's change colour and try and get this height. This height we get when x is 0. It tells us the y coordinate. So, at x is 0, we substitute y into this equation now. Not y, sorry, x is 0 into this equation. E to 0 minus 18 times 0, well that's just 0, plus 15. Anything to the power of 0 is 1, so that value here is 16. Okay, so we know this width, ln 3, we know this height, 24 minus ln 3, and we know this height. We've got everything that we need for the trapezium. Now, confused about why I'm calling it trapezium, it is a trapezium on its side. So let's just turn it around so you can see what's going on with that. Okay, I'm going to shrink it down because we are quite short on space. So we've got 16 here, we've got ln 3 here, and we've got 24 minus 18 ln 3 here. Okay, so the area, and you can do your examiner a little diagram, equals 16 plus this one, times a half, times ln 3. So it's going to be 40 minus 18 ln 3. Apologies for the messiness here. Trying my best to fit it in, I assure you. I'm going to change colour so you can see. I think 18 ln 3, and hope we don't make a mistake now with all that. We'll put this ln 3. Okay, now we want to integrate to find this blue area that we talked about. So we're going to, I'll do it down here, we're going to integrate our function between the limits of 0 and ln 3. And our function is e to 2x minus 18x plus 15. At this stage you should be thinking, I'm so glad they've given me a nice integral. Okay. So when we integrate e to 2x, we get a half e to 2x when we undo the chain rule. Minus 9 x squared plus 15x. Okay, and we're going between ln 3 and 0. Right, I did warn you that this would be messy to fit in. I'm going to use a little key. So cross, we've used this already. Going to go up here. Obviously in your exam you wouldn't do it horribly like this, you'd have lots of space. Okay, we're going to evaluate at ln 3, so we get a half e to the 2 ln 3, which we've already practiced evaluating, a half e to ln 3 squared if you remember, which is 9, so don't start thinking that's 32. Okay, minus 9 ln 3 squared, and that is just the ln 3 that's squared, plus 15 ln 3. Okay, that's the first limit evaluated. The second limit evaluated at 0. That's going to go, that's going to go. We're going to get e to 0 is 1, so it's just minus a half. Okay, and now, wow, what a messy page. Okay, now I'm going to try and simplify it on the spot. So e and ln are inverses, so you're going to get 9 over 2 here. This squared we are going to leave for now, 15 ln 3. All that is going to simplify, and I'll do a little diagram here. It's actually like that, isn't it? All that is going to simplify, 9 over 2 minus a half. is just going to be 8 over 2, which is 4, minus ln 9 ln 3 all squared, plus 15 ln 3. Okay, and remember, we're doing this, take away this. So, final bit of erasing, hopefully, and then an answer. We are now doing our trapezium bit, take away our curve bit. And first of all, I'm going to expand out this. Okay, so we're going to get ln 3 over 2 times 40, which is 20 ln 3. We're going to get minus 9 ln 3 squared. That's handy, that looks familiar, doesn't it? Okay, and then we're taking away 4. The signs are going to swap when we're taking it away. Plus 9 ln 3 squared. How cool is that? Plus 15 ln 3. Okay, that's going to cancel with that. So we're going to get 35 ln 3 minus 4, and it's square units. Okay, so you've just got to carry on trying at that question, keep going until you get it. I think that's the last one. Okay, so hopefully we've got full marks. Core 3 is quite tricky, so we might not have done. If you notice any mistakes, obviously just give me a comment. If you have any questions, give me a comment. I'm happy to answer all of your questions. I'm trying to help you to achieve the best that you can in maths. Okay, thanks for watching. Achieve Maths. Goodbye.